This video presentation is about self-building a big rig. I'm Thomas from fabhubs.com, and I was initially going to do this talk at Adventure Overland 2020 in Stratford-upon-Avon, but because of coronavirus that was cancelled, so I'm going to put it up online so that people don't miss out. So dissecting the title, we're talking about big rigs, and what I mean by that is big rig overlanders, overland trucks, or heavy overlanders, lots of names for the same thing. Essentially, they're heavy goods vehicles or lorries converted into motorhomes, generally above 7.5 tons. I've put 3.5 tons here. There are some under 7-ton ones. But we're not talking about panel vans or pickups, 4x4 cars, anything like that. And self-building, we mean that you do everything. Now, there are lots of companies that will take your money and deliver excellent vehicles. They generally run about 6 or 7 figures. And if you're looking at about 5-figure budget, under 99,000 euros, you really have to build it yourself. Now, there is some assembly as possible. You can have panels made and assemble them yourself from a kit. But generally, most people end up finding they do almost everything themselves. So ideally, the process of designing a vehicle would look something like this. A simple linear process where you take your initial vision, you make a bunch of requirements that are specific to you, you turn those into specifications, which include facts and figures and engineering things. You produce a bunch of designs and plans which show where and how everything is located and connected. You turn that into a build plan, which is a sequence of events that has to happen in a certain order, and then you just build it. But in real life, it's much more complicated than that, and most things are not linear. You get to the design stage and you realize you need to change something, and then that changes your specification and you have to go back, and that affects your ability to meet a requirement, and so you have to go back. Lots of complications can occur, but generally, ideally, it would look like this. And most of what we're going to talk about later comes down to how can we approach this so that it does happen more like this, and it happens in a less organic and more systematic way. But it's clear from the number of half-finished projects that end up on auction sites like eBay that it's more complicated than that. Not everybody finishes their project. And I put together 4 reasons why I think these projects don't succeed and what we can do to counter them. So very quickly, the 4 are: number 1 is underestimating the size and effort of the project. These are huge projects and they take a lot of time. And if you don't know that going in, it can very quickly take over your life and lead to people wanting out of the project. The second one is budget creep. It just ends up being way more expensive than people thought. They can't afford it and they have to sell, cut their losses, and abandon the project. The third is morale erosion. This could be that they just can't face doing it anymore, or it could be that the project was so stressful it led to a breakup of the relationship between build partners, and therefore the project can no longer go ahead with only half the resources behind it. And the fourth one is less of a direct cause of failure, but it's just something to be aware of, which is goal drift. People start out with one vision, but over time they end up making something completely different. So let's have a look at these 4 in more detail and learn what we can do to protect ourselves against these common failures. So let's start with project size and effort, which most people underestimate. And I'll just put a quick comparison together between a panel van conversion and an overlanding truck. Most panel van conversions take between 500 and 1,000 hours. You can obviously spend more than that, but I think it's quite difficult to spend less than that. And I think most end up taking around 1,000 hours if everything is taken into account and considered. Now, heavy overlanding trucks or big rigs, they take about double to triple that, potentially a lot more as well. It wouldn't be crazy for it to take 5,000 hours. Now, the main reason for the difference between a panel van and the truck is that with a panel van, you're starting with a watertight metal shell, and in the truck, you've got to build a box and connect it to the chassis and all of that. But even if you were to start with a shelter or a container or something, the number of modifications you're going to have to do to make that box habitable is just a time-consuming task, and it takes a long time. So I think whichever way you look at it, whichever approach you're going to take, whether you're doing composite body or a Zeppelin shelter or you're going to build one from scratch, at least factor in 2,000 hours. And I think probably somewhere in the middle of that range is better. It's really important that we give these numbers some context because most of us aren't using man hours in our daily life, and it's not a very intuitive metric. But 2,400 hours, which by the way is an extremely realistic estimate for a project of this size, if we split that evenly between two people, it's 1,200 hours each. Now, 1,200 hours to an individual looks like every weekend, so that's 8 hours a day, Saturday and Sunday, plus 1 hour every weekday, after work, let's say, for an entire year. Or full-time, it's 8 hours a day, Monday to Friday, for 7.5 months. So it's a huge project, it's a huge undertaking. And it's worth stressing that this is on top of your daily chores and activities. If anything, it adds stress and it adds chores because you're going to be changing clothes and washing hands and commuting to the workshop and stuff. So all in all, is spending every weekend and an hour every day for an entire year, is that realistic? Now, the only way that you can determine whether or not this is realistic is if you make a plan that fits around your existing life. So if necessary, you're going to have to push your deadline back and allow time for weekends off and breaks and rest periods and socializing with friends. Otherwise, it will consume all of your free time and it's going to start to affect morale, which we're going to discuss later. It's also worth mentioning that injuries and accidents are much more likely to happen when it's late in the evening, you've had a long day, you're tired, you're hungry, you're dehydrated, you're rushing to get it done before dinner. That's when you're likely to hurt yourself. It's important that you know when to stop and that you don't push yourself towards making silly decisions when you're actually in the workshop, because some of the stuff can be quite dangerous. Make a plan, make it realistic, and if it is becoming too much stress and too much effort, and if it's affecting morale too much, you've got to adapt it as you go to keep it realistic. The second reason that these projects don't get completed is because people underestimate the cost of the project. Now, most people who even complete the project, they also underestimated it, and the project ends up over budget. But this is particularly true to self-builders who are probably self-building because they're on a lower budget than people who can afford to go and outsource it. And I'd say if you're on a budget, if you're trying to self-build on a budget of under about £30,000, you really need to keep a close eye on your costs and watch them like a hawk, because they can quickly escalate to double that if you're not careful. And one of the best ways to be careful and to keep the costs manageable is just make a list of all of them. Now, some are really obvious, and I've put a few here. It's really obvious that you're going to have to buy a vehicle. It's really obvious that you're going to have windows and doors and a fridge and a bed. All of the things that you see, touch, feel, and interact with on a daily basis, these come quite quickly to the mind, and it's quite easy to jot down a list of them and go on eBay and find prices for everything. But what we mustn't forget about is all of the other costs that are required to complete this project, because it's not about the truck, it's about completing the project. And one thing that most people neglect, or at least underestimate, is fixings, fittings, adhesives, that type of thing. We're talking nuts, bolts, screws, glues, sealants, washers, paint, that kind of stuff. because we don't see it, because it's hidden behind the walls or inside things, they don't immediately come to mind. And also, when we do think about them, we dismiss them. How much is a box of screws? Not very much. But the sheer number of screws and bolts and rivets that are going to go into your truck mean that they are significant costs, especially adhesives and sealants. If you're doing a composite build, these will actually be quite a large line item on your on your total cost summary. I met a couple who had converted their own MAN truck, and he told me that he had used 50 kilograms of sealant in his build, and it wasn't a particularly remarkable build. It wasn't completely waterproof like an aquarium inside or anything. It looked pretty normal, but he had counted 50 kilograms, which is about 150 tubes of sealant. Now, a cheap tube of just standard silicone could be £5, but an expensive adhesive that's designed for a specific application or temperature range or material could be £25. So 100 tubes could work out to between 500 and 2,500 pounds, and almost nobody is going to go into the project with that kind of budget for adhesives and sealants. Even less obvious than these things are things like consumables. Now you're going to go through, if you're working with steel, you're going to go through a lot of grinding discs. You should be going through a lot of PPE and clothing. You should be going through a lot of solvents and cleaners if you're reusing paintbrushes and stuff like that. And all of those little costs, welding gas and wire, sandpaper and files, drill bits, saw blades, electrical connectors, masking tape, that's a big one. Again, they're not very expensive, but you're going to use so much of them that they do add up. And also, if you forget something and you have to go back, just go all the way to Toolstation or Screwfix just to get a roll of masking tape, that's going to cost you in petrol. Which leads us to enablers and incidental costs. Now, these are probably the least obvious ones, and they're probably the most individual because it really depends on your build situation. If you're renting a workshop far away, you need to be taking into account workshop rent and commuting, petrol, and maybe depreciation if you've got a finance car or anything like that. Even if you've got an on-site workshop and you can just walk to it, there's still going to be issues like, are you insuring the workshop and your tools inside it? If not, you're opening yourself up for the possibility that they get stolen. Are you are going to get MOTs and the truck tested and weigh bridges, things like that. These things have costs, and it's worth trying to put a figure on each one. If you assume the cost is naught, it's the one number that's definitely wrong. Everything has a cost, and it's worth figuring out what it is. And some of them are less obvious, and sometimes you're going to end up, if it's taking up a lot of your time and you're eating into your evenings and your weekends, you're going to end up paying for convenience. You're going to end up getting more takeaways, having food delivered to the workshop, whatever it is. Try and put an estimate on these things because they are going to happen. And don't forget about mistakes, accidents, rework, practice, late changes, and other unfortunate events like theft. These happen to everybody. Practice is just necessary. Sometimes you might have to go and, if you're going to practice welding, for example, you might have to go and take a course. You might have to get somebody to give you some pointers, and it's going to cost you a few beers. You might, definitely will, need to have some offcuts of metal to practice on and get the settings right on the machine and things like that. I'd probably try and factor in 10 to 20% of relevant costs as mistakes, accidents, rework, and practice. At least it gives you that buffer, and it removes the stress so that if you make a mistake and you break something, it's not the end of the world. You have a contingency plan for it. The only thing you can do here to get these costs right is to go through these categories, try and think of absolutely everything possible, and put a figure against it. Remember, if you put 0, it's the one number that's almost definitely wrong. Everything should really have a cost, and give yourself some safety margin. It will mean a huge amount to your future self when you do inevitably make a mistake, even if you've measured 3 times. If you can't afford to go and get another whatever it is you've just messed up, it's going to be an extremely stressful and dejecting experience. So have some leeway and order in a bit more materials than you need. You can always sell them. Maybe you won't get all your money back, but you can always sell them on later. The third reason lots of these projects fail is not because people can't afford it or they don't have time for it, but because they just can't face doing it anymore. And this is called morale erosion, and it's a very real thing. Lots of these long-term projects become tiresome, and the only thing you can do to combat it is to expect this and to prepare for it. It's worth overestimating the number of hours and incorporating that into your routine. If you get halfway through and realize you're way past half the number of hours you thought it was going to take you, it can be extremely demoralizing. And the initial excitement and enthusiasm of the project will wear off, and then it takes grit and resolve to get the project done. Now, if you've got a really good plan, a build plan, which is a sequence of activities that needs to take place, it makes it way easier to go into the workshop when you don't feel like it, because all you've got to do is begrudgingly go, look at the plan, look at exactly what needs to be done, and then crack on with it. So when your mood is up, make sure you're updating the plan and keeping it up to date and breaking down the activities into a level which you can follow when morale is low. It makes a huge difference. And if you're thinking, well, I have lots of friends and family, they're going to help me and this is not going to be a problem, unfortunately, I have some more bad news. Generally, your friends and family won't be much help. Just think about it in terms of those 2,000 or 2,400 hours. How many hours are they actually going to come to your house and work for? And it's not going to be 1,000. Maybe if they're a good friend, they put in over 100 hours. In my experience, most people probably put in under 10 or 12 hours in total. Now, I'm not saying exclude them from it. It's important to include them in the project and let them see what you're doing. It's going to take up so much of your time and it's going to take up so much of your attention that if you don't incorporate them into it, they're going to start to resent it and eventually you. I'm just saying, when you make a plan, make one that doesn't rely on support from uninvested parties. Now, if you've got a husband or wife or partner or business partner or best friend who you're doing the project with and they're putting money into it as well, those people you can rely on. You have to rely on them because you're making a plan together. I'm talking about uninvested parties, your cousin, your sister who lives 100 miles away. Those are the people that, and it's not their fault. I'm sure they have the best intentions in the world. It just comes down to commitment and number of hours. But talking about that husband or wife or business partner or best friend, whoever your invested parties are, it's worth talking to them and having a discussion to them or with them about what it's going to look like when you guys are both hungry and tired and cold and you've lost tools and there's been a communication breakdown or something goes wrong. It's a recipe for arguments, and everybody is going to have arguments when morale is both low. So you need to be aware that it will stress the relationship, and you need to learn to work with your build partner, whoever they are, and learn when it's time to call it a day and when it's time to for one of you to go and get some alone time. It can be an extremely rewarding experience, and it is at the end. It's an extremely rewarding experience, and if you manage to make it through, your relationship will definitely be stronger. But there are some parts in the middle when it might put undue stress on the relationship. So make sure you've got a solid relationship beforehand. Otherwise, you risk losing a friend or worse. And just talking about morale in general, I just put this quick graph together. Things start to ramp up just as you prepare for the vehicle purchase. They probably peak at or just after the vehicle purchase when you're most excited. The possibilities are endless. It's real and it's happening. And the initial few tasks are probably quite fun and enjoyable, but it's slowly, the novelty wears off, it gets harder and harder, the jobs get longer and longer and more tedious until it becomes a bit of a chore, actually. And from that point on, we're going to call the slog. Now, the slog is probably the longest phase in the project. That's where it takes grit and resolve. That's when you need to motivate yourself to get back into the workshop, to finish those jobs. And if you can find enjoyment in small tasks, that's great. But generally at this point, during this phase, progress is quite slow. The visible results are quite small. And if they are large, then they are short-lived. But as you get closer and closer to the end of the project and it starts to come together and it starts to look like something, the morale starts to pick up again, leading up to when the project is complete. Now, there's always going to be little bits and bobs to do, so you've got to make a call and say it's finally done. Most people say this is when they spend their first weekend away in it, or they take it for a test run or a shakedown. But when you're in the slog, you've got to keep your eye on the prize and remember what you're working towards. Which brings us to our fourth reason, which is goal drift. So it's really important to stay focused on what you're working towards. And generally, I think people fall into two categories. They're either working for the trip, they've got a trip of a lifetime, a round the world trip, a 1-year sabbatical plan, whatever it is, and they want this truck to achieve that. And the second group of people is they just like the idea of having a truck. They want it to become part of their lifestyle. They want it to be there if they need it, if they decide to go on any adventures. But for them, it's really about having the truck that's able to go anywhere, rather than they have a specific trip they want to do and the truck is their vehicle for achieving that. So let's say you started in the trip mentality, it looks pretty simple. You build your truck, you plan your trip, and then you go on your adventure. But people fall into this trap. Along the way, they talk to people, maybe they talk to some truck people, maybe they talk to their colleagues at work or their uncle who was in Africa in the 60s. And they slowly make decisions that are veering away from their initial goal. And almost always, the decisions that you're deviating from, they're more expensive, bigger, heavier, harder, better, faster, stronger. They're increasing the weight, complexity, and cost of your project. Rarely do people sort of trim down and make their build more lean as they go along. And you've just got to be mindful of how these distractions appear. And the best way is to write down your vision and write down your requirements. And when something like this presents itself, just ask yourself, is this necessary for my vision? Is this necessary to meet one of my requirements? And lots of the sentences that people say, they always start in a similar way. They start with, oh, well, if it were me, I would, or what you want to do is, or what if, and then they say something, what if you come to a really deep river and you have to cross it? Better make it amphibious. Try to ignore these things, unless the person you're talking to is an expert and they've been there and they've done that, in which case maybe don't ignore them. But you've got to understand, you can't prepare for everything. You have to design a truck for a certain set of requirements, and there's always more you can add. It can always be more luxurious, but if you're on a 5-figure budget, don't be benchmarking yourself against a 7-figure show truck. And a really useful tool for avoiding this trap is to write down what you're not doing as well as what you are doing. Most people write down what they are doing, it's implicit what they're not doing. Sometimes it's worth having an explicit list of what you shouldn't be doing or what you've decided not to do. And an example of this could be, you are not going to fit a winch because winches require a large anchor point, like a tree or something, and where you're going there are no trees, so there's no point in really having a winch. Or you're going to wait until other people come and recover you, and you're not going to carry a winch. It saves you a few £1,000, saves you a few hundred kilograms. It's a perfectly reasonable decision to make, but write it down, because it's going to keep coming up, and it's good to remind yourself, as well as anyone else who looks at it, what you're not doing. So we've talked about a lot of the ways that these projects fail and don't get completed, and I think now it's time to talk about how we can approach the project and how we can expect success. So let's dive into the engineering approach behind building a vehicle like this. So I flashed this ideal process up before. It's worth just reminding ourselves about it. It goes requirements, specifications, design, build plan, and then the build. Requirements are human sentences like, I want to be off-grid for 7 days. Specifications include facts and figures like the water tank needs to be 350 liters. The designs include the physical layout and the assembly of different components, and generally these are all building up to a 3D CAD model. The build plan breaks down how you're going to realize that CAD model, the sequence of steps. First you're going to put a floor on, then you're going to put the walls up, and then you're going to glue them together and clamp it, etc., etc. And then the build is what you actually do, how you follow the build plan. But I want to just propose another way to think about the project for a second, which is as a sequence of 1,000 decisions. And I reckon 1,000 decisions is about right. Each decision is made using facts, data, and prototypes. We don't just make up the answers, we do our research for each one. We put them together into a realistic plan, and the key word there is realistic. That's achievable. That's designed to meet your requirements. And then you build it. It's essentially the same thing, but we're just going to think about all of these things as the whole process as a process of making lots of different decisions. So each requirement, there will be lots of different options. Like there will be lots of different 350 litre fuel tanks. There'll be lots of different ways to heat the truck, and you have to decide on one way. So the engineering specification might say you need a 2,000 watt heater, but it doesn't say if it's going to be powered by diesel or powered by propane or be electric or use some kind of storage device. That's a decision that you have to make. And this chart here is showing time progressing on the x-axis. The initial decisions are big, and gradually over the project they get smaller and smaller and smaller, but they become a lot more of them. This is a good way to think about it. So way over on the left we've got the external dimensions of the vehicle, whether it's 4x4 or 4x2, the actual floor plan of the living area. And way over on the right we've got things like the paint color and the fabric. Less consequential decisions, but still decisions that need to be made nonetheless. And the key thing is that whatever you decide, you do have to make decisions for all of these things. You can let fate decide for you, or you can just always choose the cheapest option, but you do still have to have some way of deciding. And just for what it's worth, this is only about 180 shapes. I reckon 1,000 is more realistic. So we have all of these decisions that need to be made. And we take one decision as an example. We have to realize that every time we make a decision, it's about making trade-offs with other variables or qualities. So if we take this one as an example, increase the length of the habitation box, so have a longer box front to back, we're going to affect other variables. We can't make that decision independently. And this diagram shows a few variables that increasing the length of the box has an effect on. It will increase the weight, for example, and it will increase the cost of the project, and it will reduce the choice of base vehicles. But it will also be more comfortable inside and give you more space inside to do something with. And it's worth remembering again that as the weight changes, the weight might change again the choice of base vehicles and again the cost, and they're all interrelated and interdependent. There's a whole science set up for decision science and making these trade-offs, but all you have to realize is that when you change one thing, it's always at the expense of something else. If you want a smaller, more reliable MPPT, it's going to cost you more money. So the trade-off is you pay more money for a more reliable and a smaller form factor of MPPT. So the question becomes, how do you make a decision given that each decision has lots of interdependent effects on other variables and there's so many of them to make? It seems like it'd be impossible. Well, it's not impossible. It's quite easy. You just have to follow a simple set of rules and keep iterating. That means keep repeating this process. So the first thing to remember is that just firstly accept that it's not going to be exactly right first time and that it might be a range. Secondly, apply all of your hard constraints first and bookend the problem. So try and get a min and a max so you're working within a range, and then your aim is going to be to narrow down the range. Once you've got your bookends from your hard constraints, which might be things like the law and the laws of physics, geometry, your budget, whatever it is, then you start applying your soft constraints. These are preferences, things that you decide based on your requirements. And then if it's still arranged by the end of that, test, prototype, discuss, and then go back. So now you've got another range. Are there any more hard constraints? Are there any more soft constraints that we can apply? And if it gets to the point where you haven't settled on one, but you have no preference and both fit the bill and meet the spec and meet the requirements, then just choose the cheapest one. There's two mantras it's worth repeating to yourself as you go through this process. The first is, good enough is best. Sometimes it's referred to as best is the enemy of good, or perfect is the enemy of good, or whatever. Basically, it doesn't have to be perfect, it just has to be good enough to meet your requirements. You have a lot of decisions to make and you have a lot of hours ahead of you. Don't waste it on ultra optimizing small decisions. Just make a decision, record why, and move on. And the terms industry standard and best practice, these mean that somebody else has done the hard work of analyzing and testing all the variables and coming up with a standard result that's used across the industry. Now, when I say industry standard, obviously we're talking about relevant industries. So for the electric system, it would be, you should be looking at automotive or motor caravans, or maybe yachts and marine applications. There's no point looking at semiconductor industry standards. You're not going to be dealing with semiconductors. All of that stuff is going to be done for you. So decisions like which type of cable should I buy, you could go away and do an analysis of all the different conductor types and sheathing materials and durability requirements and temperature ranges and all the different manufacturers that offer them, and come up with a spreadsheet and eventually decide on a specific cable that's right for you. But that's going to take you a lot of time. Much better to just decide that you're going to use automotive standard Class B cabling throughout your project. Saves you time and it will probably save you money. So let's do a decision case study. Let's look at one variable. In this case, it's the height of the build. And let's just work through it and apply these 5 rules so you can see how it would go in practice. So we've got our truck and we need to know how high is the total truck going to be once we've built everything on the back of it. The first rule to remember is that we're going to accept that decisions will not be right first time and they might be a range. So we're not going to expect to jump immediately to a millimeter precise figure. We're just going to work on a range and try and narrow it down. Eventually though, we are going to have to cut the metal or fiberglass or whatever it is to millimeter accuracy. So it does need to be millimeter accurate in the end, but just not straight away. First, we set our hard constraints. That's geometry, the law, and by law I don't mean the laws of physics, I mean, although that also applies, I mean local laws, and your budget, which I put as a hard constraint because we don't want to treat this as a soft constraint at this stage. So if I draw a height scale on the right hand side here, so we're applying our hard constraints first, and the truck that we've bought, in this case it's a Leyland DAF, but the figures are just approximate, so if you're building on this platform, don't double check these figures. The truck itself is already 2.7 meters high, so we've already got our minimum height, unless you're going to be chopping the roof off and putting something very low on the back. And I really don't think, I think you, at this, if you're going to consider something like that, you should be considering changing your base vehicle. Let's go with that as the lower end, 2.7 meters. So now we need an upper end to counter that. So I've gone online and I've looked at the different laws in various countries. Here in the UK, vehicles up to 4.9 meters are allowed. But let's say our requirements are that we want to be able to drive out of the small island that is the UK and onto the continent of Europe and maybe beyond. Europe sets a maximum standard vehicle height of 4 meters. And America, Canada, and South Africa have put, they're somewhere in between that range. I think they're 4.5 meters, lots of them. But Europe is the lowest one. Let's set our max hard constraint at 4 meters. Now, looking on the right already, I've oranged out all of the ones which we're not considering, and we've already got our range down from 0 to 6 meters down to 1.3 meters, between 2.7 and 4 meters. Now, it's still not precise enough to cut metal, but we've only done the hard constraints here. So let's move on to the soft constraints. Now, these are based on our requirements, and let's say that for the purpose of this example, one of your requirements is that you want to be able to stand up without crouching in the back of your truck. And based on the height of the tallest person who's going to be living in the back of the truck, that brings our new minimum up to 3.25 meters. So we've already got a range of only 75 centimeters left to narrow down on. And we're getting pretty close. We're starting to get a good feel for how high or low the vehicle could be. So we move on to our soft constraints. Now, one thing we omitted when we added our height onto the back of the load bed before was that we're not just standing in the open air. There are going to be walls or floors and ceilings in between us, and they need to be of a certain thickness. Let's say that you've already decided that you're going to be going to cold climates and you need 75 millimeters wall thickness to accommodate, let's say, 60 mil of insulation. So that we add 2 times 75 millimeters into the height, and that takes us up to a minimum of 3.4 meters. Now at this point, the people walking around in the back, the tallest person, it looks like in this example the woman is fine, but the man, every time he's walking around, his head is going to be brushing the ceiling. And if you're going to be installing LED lights that are sitting proud of the ceiling, or you want any space whatsoever to move around, you're probably going to want a bit of headroom. But every millimeter of headroom that you add, you're taking a millimeter of headroom away from something else. So this is the trade-off that we're making. At this point, we're trading between the accessibility of the vehicle to pass under high bridges or pass in tunnels or under cables versus the interior headroom and the comfort of the living area in the back. This is the main trade-off we're making. We're making other trade-offs like increasing the height will slightly increase the weight, etc. But this is really the main one that's being considered at the moment. And there's really no way to make this decision and be completely certain about it because preference is involved. It's very difficult to look up standard values for headroom. Most of them are for residential properties, houses and flats and stuff. But most people agree that higher ceilings is much nicer and more comfortable. and low ceilings makes small places feel even smaller. So we go to our only solution, which is to test, prototype, and discuss. And for this, I recommend actually going out and seeing if you can get some data on the types of bridges, the heights of bridges in the places where you want to go, and if there are in some specific, extremely remote areas, if there's any height restrictions on accessing those areas, so that you might be able to set your max, reduce your max a bit. But if not, it comes down to headroom, and you need to go and test it. Now, there's not very many places where you can walk around and have a headroom under sort of 2 meters, but what you could easily do is set up a board and do some activities underneath the board as if you're inside a box with that limited headroom. So let's say you go away and you've set up a board at different heights and mounted on the wall, and you've made it adjustable, and you've tried to spend some time under there, say at least an hour, doing normal things that you'd be doing in the truck, so cooking, walking around, and you've come to the decision that you're more than happy with 20 centimeters of headroom. 10 centimeters would be okay, but you'd feel enclosed and a bit claustrophobic, and 5 centimeters is horrible, and you'd keep brushing your hair and scalp on the ceiling, and especially if you wanted to fit any lights and stuff. So you write those things down. Those are the results of your experiment, and that's actually enough. At 20 centimeters of headroom, we're at a total vehicle height of 3.6 meters, and we know all of the factors that have gone into making that decision. It's really important, once we've made a decision, that we record why we've made the decision. And this slide, what you can see in front of you now, this slide would be perfectly adequate for doing that. It shows you everything you need to know: the height of the load bed, the insulation, the height of the people, the experiment that you've done, and the laws and the preferences about staying under 3.8 meters. Everything is contained on this slide. If you make this decision and then 6 months later decide you want to add solar panels onto the top, which are 50 millimeters thick, you can come back to this slide and you can easily determine, yes, you can add them onto the top, or yes, you can drop the ceiling height by 50 millimeters at a slight expense to comfort inside. But both of those are possible. If you haven't made this slide and you haven't kept a record of it, when in 6 months' time you come back and ask if you can drop it by 50 millimeters, you'll just have vague memories of these things. You have so many other decisions to make that this one won't stand out compared to all of the others. So do keep a record. It is really useful later, but don't make it more complicated than it needs to be. This slide is perfectly adequate. So looking again at the decision-making process, we can see we started out with one of the external dimensions on the very left, and we made a decision following this quite simple process. Now, yes, there are lots more to do, but generally they get easier, and generally as we go more towards the right, it becomes less about these hard constraints and about laws and about the laws of physics, and more about what looks nice and what costs a lot of money. And generally later on, that's going to be the big trade-offs that you're going to have to make. If we make decisions in this fashion and we record why we've made the decisions, it helps us stick to this ideal linear process. Now, I said before that it's never in reality completely linear, because you find things at the design stage or even in the build stage and you have to go back and rework something. But if you've kept a record of why you've made all these decisions, it makes it really easy to go and modify them later. And the process of doing the research in this systematic way and coming up with these slides or these summaries of each decision that's been made, that gives you a really strong foundation to make these technical decisions and to make these on-the-fly decisions during the build stage later. Now, we've talked about there was 4 reasons for failure before. It was underestimating the effort of the project, underestimating the cost of the project. It was morale erosion and goal drift. But if you've got a solid set of requirements, there should be no goal drift. If you keep reminding yourself of them, you know what you're supposed to do, and remember what you're not supposed to do. If you've got a solid specification and design, you're going to also have a solid list of all of the hardware and all of the costs that go into that. And you're not going to be massively underestimating your costs if you've done everything properly. And if you've got a solid build plan, you know how long it's going to take you. You know realistically how you're going to be able to fit that into your life, and you're not going to run out of time or have to push your deadline back an entire year without knowing it. So remember, the objective is to try and follow this ideal linear process, knowing that we'll never do it, knowing that it will never be linear, and we'll always have to go back and iterate. But it's the act of trying, and it's the act of working in a systematic way that makes us much more likely to succeed. And if you're still with us here and you're excited and you still want to take on a project like this, I wouldn't blame you if you're not, because it is a lot of work and we've talked about a lot of negative things, but that doesn't put lots of people off, and many people succeed in making their dreams reality. And if you're looking to do the same thing, I suggest that you come and join us at overlandingtrucks.com. There's a forum specially for heavy overlanders and overlanding trucks, where you can ask for help from some of our more experienced members, and we'd love to also follow along with your build and see what new things you bring to the table. It's not a very big community that you're joining, and it always helps to be able to reach out to people and to share your frustrations and ask for advice where possible. There's also a very good book by Steve Wigglesworth, who's a member of that forum, called Build Your Own Overland Camper. It's a Haynes manual. It's not very expensive. I suggest, if you're thinking about a project like this, that you get yourself a copy on Amazon and read through that, paying attention to all the detail on every single page. He covers quite a few different examples and has a few case studies in there, and I really think it's worth the money. There's also another book by Ulrich Dold. It's a translation from a German book, which is about his journey building his motorhome. It contains a lot of very technical information. It's quite specific to his build, but it's a great companion to the other book. And of course, you can also go on Facebook, find some Facebook groups or Reddit communities or YouTubers who are doing similar things. But ultimately, it's going to be your truck. It's going to be quite unique to you, and nobody else can tell you exactly what to do. We can just point you in the right direction. Thanks very much for watching. I hope you've found it educational and you've enjoyed it. It's a shame we couldn't do it in person, but hopefully the Adventure Overland show next spring, April 2021, will go ahead, and you can see me there, and you can see some of these trucks in the flesh and in person. If you want to get in contact with me before then, go to fabhabs.com, fill in the contact form there, and I'll try my best to get back to you.